this responsibility to reduce carbon, and we've all got the ability to influence change. And I'll hopefully give you some insight into how we as consultants and as part of the wider supply chain are responding and what we're learning. And I hope you'll take something away from it that you can use. So first of all, an apology. Graphs are, I think, compulsory when you're talking about carbon, but I'm going to try and keep them to a minimum. The last 20 years have seen us increase global carbon emissions at a record rate, and there's now twice as much CO2 in the atmosphere as there was before the Industrial Revolution. And what this graph shows is that we've already missed some of the best chances for reductions to keep temperature rises below the targets that were set by the international community in Kyoto and Paris. But whichever path we take to limiting temperature rises from here on in, we've got to start now. In the next decade, we need to turn that line through 180 degrees, and we've got to halve our annual emissions in the next 10 years at a global level. And I think it's probably fair to say that's the biggest political, social, economic, and technical challenge that we've ever faced. So we're very much at a pivotal moment. We're at a critical point. There is now broad global alignment, and the world's biggest polluters are either coming on board or coming back on board. Ambitious targets are being set, laws are being established, the frameworks are being put together, and all of that's great. But we have to remember we've not really yet achieved anything. We appear to still be moving away from, not towards net zero. So the COP summit in November is going to be an absolutely pivotal moment. And I think the big question is just which way we're going to pivot. The UK is one of the relatively few nations that have enshrined carbon reduction commitments into law. And the strategy that they've developed really says we need to minimise our emissions as far as possible and down to those which are genuinely unavoidable. And that's absolutely key, because we then need to balance those unavoidable emissions with removal of carbon from the atmosphere. And we only really have two tools available to do this. Neither of those has been delivered at the scale required. Afforestation, planting of trees, and carbon capture and storage simply, haven't been tested at the scale required to deliver complete offsetting of our emissions as they are at the moment. So clearly, reduction is the key part of this equation, and there isn't a magic bullet that's going to solve all of this for us. So I wanted to talk a little bit about carbon reduction commitments that are arising that lots of organisations are making, and what's the framework which underpins all of this? What are the rules, and how are the rules evolving and changing over time? So first of all, institutional commitments, it's very much a top-down process, or it has been so far. There are top-down commitments being made. The government targets have led to institutions recognising that they need to act, and recognising that they need to build in tolerance so that they can deliver on the 2050 target by meeting net zero earlier. And as either employees within those institutions or as part of their supply chain, whether we work in procurement estates, if we're suppliers or if we're consultants, we clearly need to understand what these commitments mean. And we've got to develop plans for how we're going to make our contribution to achieving them. So the framework globally is established around the concept of polluter pays. Anyone who is responsible for emissions is responsible for their mitigation, and in that sense, everyone has a role to play. We're probably all aware an organisation's emissions are divided into three scopes. So we have scope 1 and 2, which are typically called the direct emissions. Both on-site and off-site, and historically that's been the focus of reductions so far for universities led by HEFKI in their when they existed. But then we have the scope 3 emissions, that business travel, commuting, construction, all of those purchased goods and services, and those are someone else's scope 1 and 2 emissions. So there's a shared responsibility there, but purchasers have substantial influence, and through recent conversations I've been having with universities, there seems to be a consensus that might be around 3 to 4 times the scale of the scope 1 and 2 emissions. So, you know, there's a huge imperative to reduce there. So what do the institutional commitments that have been made mean? Well, in general, the net zero commitments that are being made by institutions typically refer to scope 1 and 2 only. So again, you know, is scope 3 someone else's problem? Well, I think the focus of procurement is in terms of the time and effort that's spent is going to largely be on products and services which result in scope 3 emissions. And as purchasers, we have a key role in influencing suppliers to deliver improvement, as do we as consultants. And so scope 3 emissions are in effect a shared responsibility and sit firmly within what I would term our scope of influence as purchasers and as a supply chain. There are other factors around this. Energy decarbonisation has an effect. You know, we are decarbonising energy. We're decarbonising it faster than most predictions. And with my optimistic hat on, we will get to net zero operational energy by in advance of 2050. But as we decarbonise that energy supply, scope 3 is brought much more into focus. And organisations, including universities, will start to set firm scope 3 targets, which we know from speaking to institutions are being developed. And key to that, really, purchasers will need to influence suppliers to demonstrate significant carbon reductions, this shared ownership of scope 3. So universities' scope of influence is really going to drive change in manufacturing and services. Sorry about that. So I'm an architect. You know, clearly I'm interested in and have a specialism in buildings in the built environment. So I'm going to talk a little bit about how construction needs to respond to this challenge and about what we as designers and as consultants are learning. We know that construction is a major contributor to all 3 scopes. Buildings are responsible for something like 40% of global emissions. 10% of that is through construction, which is scope 3, and 30% of that through operation, which is a mix of scope 1, 2, and 3. So it's a substantial problem that we need to address. As architects, we can influence reduction in all 3 scopes. So it's not just about reducing the energy use of the buildings we design. Sustainable master planning, which influences behaviour, maximises utilisation of assets, minimises embodied carbon across campuses, across estates is vital. Focusing more and more on retrofit and refurbishment. You know, it said the most sustainable building is one that's already built. But when we do build new, because sometimes we will have to, we need to build long life, loose fit, low carbon buildings, and we really need to start to make much more reuse and recycle more of the materials that we use in our buildings. And all of these things will contribute to reducing the scope 3 emissions. So the construction industry is in a reasonably good place policy-wise. They've put frameworks in place which define how we reduce these carbon impacts and how we start to move towards net zero. And there's a clear methodology in place for assessing the carbon impact of buildings. And it's what has been termed a whole life approach, which I'll come on to a little bit more. There's 3 key documents that define, first of all, what we must measure, and that's the European norm on the left there. The RICS document in the centre, the professional statement, sets out how we should measure carbon and how we should quantify it and the rules around it. And then the 3rd document, the UK GBC framework, sets out how we can conceptualise and set a framework around net zero carbon buildings and what we need to do to get to that point, whether we're looking at net zero in terms of operational energy only, or whether we're looking at operational plus embodied emissions, that whole life that I referred to. So there are clear frameworks, and I think, unfortunately, it's fair to say these are still not necessarily fully understood or widely followed across the industry. I think there is variation there. But if we think about the life of a building, whole life is key. We need to think about all the emissions associated with a building that we might create. So we need to look at scope 1, 2, and 3 across and beyond the life cycle of a building. So the framework set out 4 modules of emissions, A to D, which are across the top there. And they talk about, first of all, module A, the construction emissions, the upfront embodied emissions, the emissions that arise from the extraction and processing and manufacturing of materials and their delivery and assembly on site. That's all scope 3 emissions. Module B is about the lifetime of the building, and by default we assume a 60-year life for buildings. So during that time we've got the in-use carbon from the operational energy that the buildings use, scope 1 and 2. But every time we need to repair or replace a window or a facade or a roof, that also is responsible for an emission of scope 3 carbon, embodied carbon. So then module C at the end, the sort of inevitable end of a building's life, whether that be 25 years, 50 years or 100 years in the future, there are scope 3 emissions built into the design of the building, embodied emissions from the outset. You know, there is an energy implication to dismantling and disposing of the building. And the key thing there really is thinking more about the 4th module, module D, which is the circular economy aspect, the benefit that we can get from reuse, recycling and energy recovery from those buildings that we've in effect finished with. So today, our primary focus as architects, as designers, must be on reducing operational energy to get scope 1 and 2 to net zero to meet those commitments. And we still have room for significant improvement there. But we can also make significant reductions in scope 3 embodied carbon through good design and through making the right choices. Embodied carbon is going to reduce naturally over time to some extent as new products are developed and manufacturing processes decarbonize, particularly influenced by purchasers and clients. So the framework is all in place. We know what we need to do. We know the framework is there for how we achieve it, and yeah, we will need to make progress, significant progress over the coming years. So I wanted to talk a little bit about our journey so far, really, as an organisation, as FaulknerBrowns. I think, you know, we're clearly a design consultancy. We're part of a wider supply chain, and I think we recognise our responsibilities to play a significant part in carbon reduction. So we are a relatively large architectural practice, around about 100 employees in Newcastle and in Vancouver, but we're tiny in relation to the smallest university. We have signed up to the Architects Declaration of a Climate Emergency, and what that means to us is that we understand the need to make urgent and significant reductions in emissions. And we also recognise that as designers, we've got a key wider role to play. We're recognising that this is going to touch every area of our business, and that we need to start now, and that's what we're doing. So we understand our direct and indirect carbon emissions in a reasonable level of detail. As a business, we're responsible for, say, around 200 tonnes of carbon emissions per year. That's out the baseline of our carbon management plan. You know, that's not insignificant, but in terms of larger organisations, that's relatively modest. And the squares on the left, the rectangles on the left there, roughly show the proportions of the emissions that we're responsible for as an organisation. Our carbon management plan's delivering year-on-year reductions, as it should, and it's informing how we carry out our business activities. And this is absolutely right. You know, we expect to have to demonstrate our commitment to reducing these emissions, and you know, if nothing else, we need to lead by example. But there is another angle to this, and really that is about what I've termed our scope of influence, our wider impacts through the projects that we deliver, through the whole life emissions of the buildings that we design, potentially dwarf our direct and indirect emissions by a factor of 1,000. If we were to design the buildings that we delivered in 2020 purely to meet regulatory standards, we're looking at potential whole life carbon emissions of those buildings of something around 200,000 tonnes. So 1,000 times the emissions that we actually are incurring through running our business. So that's that's huge. We're not in full control of those emissions. We clearly work as part of a team. We work with clients, we work with engineers, we work with other specialist consultants. But if we only deliver a 10% reduction on that total through the design decisions which we control ourselves, then that alone is 100 times our direct and major indirect emissions. I think the reality is we typically deliver much greater impacts than this in almost every project we need to do, in almost every project we do, but we need to be doing more. And the RIBA and other organisations are setting out targets that suggest we need to be looking at 50 to 75% reductions in those emissions over the coming years. So if we work with the right designers, if we work with the right builders, if we work with the right product suppliers and manufacturers, we know that we can meet this challenge. We're absolutely confident we can do that. And these emissions are the scope 1, 2, and 3 emissions of our clients and of the end users of our buildings for the next 60 years. So this is why we talk about our scope of influence, that the decisions that we make as designers have so much significance in terms of their ability to influence and reduce carbon, far more than the changes that we are making to run our business more carbon efficient. So how do we maximise our scope of influence? Well, our ambition as a practice is really to embed sustainability into everything that we do and every decision that we make, particularly the design decisions that we make. I lead a group within the office that we've established, the Sustainable Practice Group, and that's tasked with kind of leading on this change. So the group's role is really, first of all, to learn, and there is, there's a lot to learn. There's a constant flow of new thinking and new information to process and assimilate and evaluate. We need to raise awareness. We need to adopt new tools for whole life carbon assessment. We need to embed carbon reduction into our quality standards and our quality systems. We need to develop the skills that we have in-house and provide support to project teams where those skills can be supplemented by specialist expertise. We need to identify and promote best practice in our own projects and in others. We need to engage with industry and with clients more widely. And the value of sessions like today, that's really important. And we also need to promote our successes. We have a responsibility to do that. So I think a key challenge that we face, and that you will face as well, as I was involved with procurement for large organisations, is we need to work with the people who can help us to deliver the maximum impact for our clients and for the environment. So the fact that these collaborators have a carbon management plan is good, but we really need to be working with, and it's a terrible phrase, but thought leaders who really share our commitment to design quality and to delivering significant social and economic benefit whilst having a positive impact on the environment. And that's a kind of a universal challenge. I think we all need to work together towards that. So what are we doing as an organisation? Well, this is very much not a sales pitch. With a rather lot of procurement people in front of me, I wouldn't dare. But what are the key themes that we're seeing across the projects that we're doing, particularly those in the education sector? What are we learning and how are we applying those lessons? So a few brief case studies really to talk through with you. We've invested in life cycle analysis tools, which fit with our digital suite of digital design tools to ensure that we maximise our scope of influence. And these new tools give us huge insight into the key design decisions which support low carbon design. So at the early stages of projects, they allow us to support key decisions like what shape is the building, how does it stand up, what is it clad in? You know, all of those decisions have a dramatic influence on carbon emissions. So the example I've shared here, we carried out a study based on a typical student accommodation development, similar to many that we've been delivering over the last 20 years, to really look at the whole life carbon implications of a range of different construction approaches. And this really identified an optimum approach, which we then has informed a number of projects, but we then took that to applied it to a recent project that we undertook with Newcastle University. So what we were able to do there was to make detailed comparisons between a range of different approaches, particularly to the structure and the facades of the building, which allowed us to target a reduction in embodied carbon in those elements by around about 25% in relation to typical benchmarks. So this process of learning and application to projects is kind of bearing fruit. And that learning process is vital. We deliver some great projects, and we're really proud of the buildings that we produce, and we can learn a great deal from our successes, even when perhaps they predate some of the current understanding and frameworks around embodied carbon. So for the Mountjoy Teaching and Learning Centre that we delivered around about a year and a half ago for Durham University, we know that delivers significant social benefit for students. It's a focus for the university to reform its curriculum and develop its pedagogies. It releases underutilised and dispersed space across the university for reuse to support growth and to support the kind of wider social impact of the university. And it's really a key tool for the university in maximising its impact. It's a piece of civic architecture that sits in a really sensitive heritage context. You'll see the cathedral on the left there is a World Heritage Site. It's hopefully a relatively timeless building. It's got an exceptionally compact form. The ratio of the external walls to the floor area is very small, which makes it very efficient, both in terms of cost and carbon emissions. And a whole life costing approach to that envelope was adopted to develop a long life, loose fit, and very much modular design. So the component life, the lives of the design lives of the elements of the building have been aligned to the life of the building wherever possible. So the graph on the right shows that the 75% of the envelope of the building has been designed to last 100 years. It won't need replacement during the building's life. So in effect, in carbon terms, we're only paying for one envelope. The windows were sized for daylight and ventilation, not for kind of bling or jewellery on the building. So individual windows that meet those requirements rather than fully glazed walls. And that means they can be replaced or reconfigured as they need to be, but also while the building remains in use. So again, there's a huge benefit there. So really what we find is good design decisions and good carbon decisions often align, and we need to learn from those, and we need to take those through all of our projects. We work with universities at a strategic level to inform their future estate plans, and there are carbon intelligent decisions that we can make at those stages. So at the University of Liverpool, we're supporting the university's master plan and supporting their response to the challenges and opportunities that come out of COVID, helping to target a right-sized and effective estate, a collaborative, a supportive and a sustainable campus, and really maximising the benefit of the assets the university has to support the well-being and the success of students and staff. And clearly doing that with the minimum carbon impact is important. We are seeing an increasing focus on reuse across all of our work, not just in universities. This doesn't have to be a compromise. We've recently completed Teesside University's Business School, which was a refurbishment of a 1970s library building, remodeled, retrofitted to create a new business school, which is effectively a new building. So all of that embodied carbon that's locked into the building substructure and frame, we're extending the benefit of that, as well as delivering significant savings in energy use. We're also helping to set the agenda. We work with the Department for Education to help define the framework for the future school buildings programme. And the next generations of schools are intended to be net zero in operation and low embodied carbon. They'll be fossil fuel free and will follow passive house principles. Many of you will be aware of the passive house standard, which sets very, very stringent low energy targets for building design. And really the key challenge that we've identified on that project is the challenge of meeting energy demand with on-site renewable energy generation. And I think what it highlights is large organisations, whether that be the DFE, whether that be universities, need to think about this energy provision at a statewide level, not a building level. It needs to be solved at a kind of systems level. And again, with this project, it was not just about carbon. In a sense, that the lowest carbon building is one that nobody uses. What we've looked to do is to really enhance the well-being, biodiversity and social impact benefits of a typical school, as well as minimising the level of carbon emissions. And then the final example I'll share with you is one that we're incredibly proud of. It's a new sports centre that's currently on site for the University of Portsmouth. There was a brief requirement to achieve BREEAM Outstanding. The Building Research Establishment's environmental assessment method sets a series of tiers for energy and wider sustainability performance. And it covers social, economic and environmental considerations. So to achieve outstanding, which is the absolute highest tier, we have to do everything right. So right from the earliest decisions, there's a sustainable location, a holistic approach to environmental performance, well-being and biodiversity. We had to make all the right decisions. In relative terms, it's a high energy and high carbon building type. It has a swimming pool within it. We need to reduce that significantly, but also maximise social value. Again, a building that nobody uses, still emits the carbon. We need to get the maximum value from that. And I think it's fair to say the project largely became about minimising the energy and carbon to meet this quite stringent and challenging standard. So every decision was important. The right organisational approach, a focus on achieving comfort, efficient systems, high performance fabric, and incorporating renewable energy generation. And doing all of these kind of right things gets us close to net zero carbon for the building. We really didn't have the luxury of focusing on easy wins. We had to identify and take every opportunity. But it's illustrated for us how hard it is to get to net zero. So we are still, there's still a gap there. And we've recently done a separate study with the university to look at what wider infrastructure improvements they might put in place to get us to, in effect, net zero for the building over its life. So hopefully that gives you a flavour of the things that we're doing, the lessons that we're learning, and the projects that we're delivering, and some of the challenges we're facing. And I wanted to finish off really with some key lessons, some key things that we've learned, and really things that perhaps we'd like to see our clients doing to help us to help them, if you like. Things that would help us to maximise our scope of influence over carbon emissions. So there's some key points here on how together, through this kind of shared responsibility, we can all maximise our scope of influence. So the first point, the biggest issue preventing significant reductions in energy use at the moment is what's become known as the performance gap. Buildings have not historically performed as predicted. Buildings have been designed to regulations which, in regard to energy, I think it's fair to say are not fit for purpose. And I think that is recognised by the industry and by government, and they're looking to address that. But historically, there's been substantial gaps between prediction of energy use and how buildings have actually performed in reality. But there are solutions there. As I said, we need to focus on reducing energy first and foremost. building regulations compliance calculations only address a small proportion, a tiny proportion really, of the energy a building uses. But the tools do exist to make much more accurate predictions. Accurate modelling of energy use, perhaps surprisingly, isn't part of a typical building services engineering scope, but they can do it, and it delivers huge value. I think clients must demand this. You know, there's a number of ways we can do this. There's a SIBSE document on the right there that sets out a process for much more accurately measuring operational energy, and the graph on the left shows how that TM54 standard gets us much closer to reality for a typical building. And really, this accurate prediction is critical to delivering low energy buildings and to institutional planning. The Passive House standard I've touched on very much embodies those principles, both for new builds and through the NFIT standard, through retrofit. So that's a critical aspect for us. And the other part of the performance gap is quite a specific one that we're seeing time and again across projects, and that's about air leakage and air tightness of buildings. And that's a critical performance metric that helps us to achieve low energy design and therefore low scope 1 and 2 emissions. We've got to improve this as an industry. Regulation again is totally inadequate. The graph on the left shows you, we can have an air leakage of, never mind the units for the moment, but we can have an air leakage of 10 and still achieve building regulations compliance. Almost every project we're doing now achieves 5 or better. Good practice is 3, and best practice, that kind of Passive House standard, or other comparable standards, is 1 or less. So regulations completely out of kilter. The other aspect here is that contractual targets are often insufficient. Air leakage is nobody's responsibility. It happens at the interfaces between different trades and between different parts of the building, and by the time the tests are conducted, it's usually too late to rectify the problems. So that's a challenge that we face. Our sense is that air tightness champions who can really lead and have responsibility and accountability for air tightness are an essential part of a contractor's team. And I think clients must ask contractors which named person will be responsible for ensuring that all of those gaps are closed. And I think you should expect a named individual with the experience and the power to assure compliance with the standards that are set. Otherwise, there's a gap there that we won't be able to close. So, in terms of embodied carbon, some of the lessons that we're learning, the emissions that arise from the extraction of materials, the fabrication of systems, and then their transport to site and assembly into buildings. That's a key area as I've talked about. And really the question that we've been developing answers to over the last few years is where do we need to focus to maximize our impact? How do we support and promote change? And where can we have the biggest impact? So there's a few threads there. First of all, we know that we need to refurbish, refit, and reuse much more. Structure and facades of a building can account for round about 60% of the embodied carbon for most building types. But where we must build new, this should also be our area of focus. So we need to use less material. As I said, compact, simple building forms. That gives us low energy use, but also material efficiency, and it helps to reduce cost. We've got to use the right materials for the job. We're not talking about building buildings out of straw bales and very, very low carbon materials that don't meet performance requirements. There's got to be no compromise on performance. Materials have to be long life and not require replacement during that life. And where they do require a replacement, that replacement's got to be as easy as possible. We've got to use systems that can be repaired rather than fully replaced. And clients are in a position to demand that. And we've got to start to move much more towards a circular economy, maximising the recycled and recyclable materials in our buildings, both inputs and outputs. And really that's the key to delivering the maximum carbon reduction. We've got to design for reuse of almost every component within the building. And there are ways that we can start to do that. So there are some strategic design decisions that make a big difference. We can model whole life carbon and we can use generic benchmarks for materials. But one of the questions we're coming up against frequently is how do we make informed comparisons between materials and products? How do we validate suppliers' competing claims? And how do we maximize our scope of influence and support the adoption of more sustainable processes? There's increasing adoption of environmental product declarations, and these give definitive data on emissions performance of products, and they're particularly widely adopted in the furniture systems and fit out end of the building spectrum. And they're available for the most frequently replaced building components like windows, and clients demanding EPDs and as designers, us writing them into our specification requirements will drive wider adoption and ultimately the ability to deliver carbon reduction. They're a verifiable way of evaluating and comparing performance. So we can write them into our specifications, but very much this needs client support, and therefore it needs to be part of the value system for a project from the outset. And the final kind of thorny issue is the one of cost, kind of the question, what price sustainability really? And it's a complex picture, as you'd expect. We've been asked by clients recently, in effect, what sustainability costs, and really that's an impossible question to answer. Largely, as I've tried to bring out through the case studies, it's about making good design decisions at the right time, and these are intangible, and it's impossible to allocate a cost to them. In a sense, clients are asking what good design costs, and I don't think we've ever been able to answer that. But some decisions will clearly increase or decrease cost, and what's critical, as with measuring carbon, is in establishing the timescales and the scope that we're measuring them across. So really, the key lessons that have come out for us: lowest whole life cost is almost always the lowest whole life carbon solution. And I think through the work we've done with Durham University at Mountjoy, that's really illustrated for us that, you know, if we have a low energy, low maintenance solution with a long life that can largely be reused at the end of its life, that will deliver the lowest cost and the lowest carbon over that whole lifetime, almost every time. In comparison, lowest capital cost almost always won't deliver that outcome. It's invariably not the lowest carbon solution. So my final point, really, I just wanted to finish with a piece of art by an artist called Andy Altman, which is in the Applied Sciences faculty building that we completed for Sunderland University, getting on for a decade ago now. That was a refurbishment project which increased space utilisation within the estate. It had a positive effect on the well-being of the building users. It reduced operational energy significantly. And we didn't do these things at the time to target an X% reduction in carbon. Carbon really wasn't high on the agenda 10 years ago, but we did them because they were the right things to do. And this piece of art is based on a William Blake quote, and I think really it encapsulates what universities are for, their purpose and their role. Universities are undoubtedly where the future's made, and we know that our future, in our response to the climate emergency, is going to be defined in the next decade. We literally have this decade to influence the outcome of the current levels of change. Universities must use their huge scope of influence to lead the transition to net zero carbon. The imperative to decarbonise has got to inform every decision. Institutions have got to demand total commitment from their suppliers and their consultants, and we've all got to work together. The tools and the frameworks exist to do that, and as consultants, as I've attempted to talk through today, we're making sure we've got the understanding, the knowledge and the skills to make our contribution to that. And really that's me. So happy to take any questions and to discuss any of those points.
Sorry, Ian, I was
Thank you
going
for
to
listening.
jump in and say we're on a strict 11:25 finish time today. So I'm conscious that there's a question in the Zoom Q&A and also some questions that have been posted in the Hoover app. So if it's okay with you, Ian, we'll pass those over to you and ensure that they're answered after the session.
Yes, yep. Okay.
Wonderful, thank you. I'll hand over to you then, Paul, to close the session.
Thank you. Okay. That concludes the end of our presentation. Thank you very much, Ian, for your time today. We hope you've all found the presentation really useful. The next sessions are on terms and conditions, and also there's a session on agile working. So please head back to the agenda to log on to your next workshop. Don't forget you have until 3 p.m. to enter the meme and photo competitions or scavenger hunt. And please do stop by the exhibitor stands and say hello in the booth chat feature throughout the day. Finally, thank you all very much for your time on this session this morning. And thank you, Ian.
Thank you for listening.